So good day everyone. So here is the output of the interactive LED flowing lights. So we have here the potentiometer here, so it will control the movement of the LED. So if I twist it, so the LED lights will become, the movement will become faster. If I twist it back, the LED lights movement, it will become slower. So I think that would be all for the output of this activity. So now let's go to the coding part of this activity. So we have here the coding part of the activity, interactive LED flowing lights. So let's explain this code. So in the first three lines of code, so we declare an variable. So the first variable is we have the analog pin. So this pin is where we connect the potentiometer. Then the next variable that we declare is an array. So we have a name array LED pin. So this array contains the all LED pins number. So the array have the value of 9, 8, 7, 6, 5, 4, 3, 2. So that is the value of the array. So for the next variable is we have the numLEDs. So this variable is used to tell that how many LEDs that we use in our activity. So in our activity we use 8 LEDs. So all this variable will be used later on in the code. Then for the next part is we have the void setup function. So inside the void setup is we have a for loop. So it loops all through the elements of our array. So after looping through the all elements, so it will set all the elements in that array to an output, so that all LED is the output of the our activity. Then the LED can be turn on and off. Then in the next function is we have the void loop. So inside this void loop we declare two variable, the path value and the delay time. So in the path value, so it will get the value from the our potentiometer, so using the analog read function. Then in the delay time variable, so it use a function called map. So this function convert the value into a delay range. So the value that we get from our path value, so it will convert it into a delay time range. So this delay time range can be used to control the LED lighting or the movement of the LED lights. So it will become much faster or slower. So that is for the delay time. So after declaring the two variables is we have the for loop. So we have two loops inside this void loop. So for the first loop is it handles for the forward movement of the LEDs, and the other for loop is for the backward. So first let's explain the first loop. So same as the other for loop. So first we initialize our for loop. So we have an int equals 0. So we initialize it to 0. So this 0 will act as our first LED. Then after initialization, so we set a condition. So 1 less than the numLEDs, which the numLEDs has the value of 8. So this loop will stop until the condition is met. So after we set the condition of our loop, then is we have the incrementation, so I plus plus, so every time we iterate through our loop, so we add +1 to our I. So after we initialize and set the condition for our for loop, so inside this for loop is we have the digital write function. So this digital write function, so it will set the LED to turn on. Then with the delay function, then delay time variable as an argument for our function. So this delay function, so depends on the path value. So if the path value is low, then the delay time is faster. So otherwise, so if the path value is higher, it means that the delay is low. So it will basically it will, if the path value is low, so it will make the LED movement, so it will light up faster if the path value is low. And if the path value is higher, then it means the movement of LED lights then will become slower. So after the delay function is we have the digital write again, but this time we set the LED back to turn off. So this process will continue until the condition fail. So which is the condition is I is less than the numLEDs, which the numLEDs has the value of 8. So the next one is the other for loop. In this for loop, so it will controls backward instead of forward lighting of the LED. So here it's same. So in for loop we initialize it, instead of I equals to 0, so we initialize it to I equals numLEDs and -2. So the reason we initialize it like this, so to numLEDs -2, so that the last LED won't lit up or turn on twice. So basically we initialize this to skip the last LED, then go to the second to the last LED. Then after that we set the condition same as other one. So the backward condition, so it's not same, so I greater than 0. So after the condition, so we increment each loop. So instead of I plus plus, so this one in this loop it's I minus minus. So same as the other loops, so instead of the forward turning the LED on, so this one it will turn the LED on backward. So basically same process. So using the digital write function, so we turn the second to the last LED to turn on. Then with the set of delay, so we turn it off back again using the digital write function. So I think that is all for the explanation of the code for this activity. So thank you all.